let's cover the statistics student guided notes and practice. We're going to start off with key definitions. This might take a couple of videos because this is a pretty substantial packet and took me a few days to cover it in class. So I would expect it would take at least probably 2 or 3 videos to do this as well. All right, for population, this is the most important thing that you study when you study statistics. It's what everything is based on. All right, the population is the entire group that you want to study. Okay, every individual object or unit of interest. Individual. So when you see the words entire, the words every, the words all, that is the representation of the population. Okay, then there is a sample. A sample is a subset of the population selected for measurement. It's used when studying the full or entire population is impractical. Okay, so this is the way I like to think of it. If you have, pretend like this is our population. This is, and we'll just use JCC students. This inside of this bubble is every single JCC student. All right, if that's the case, so I'm just going to do some dots that are not going to be near enough to cover every student in our population. However, a subset, a sample of the population, is just a small portion of the population. Okay? An important idea, a population is the entire group we care about. A sample is the smaller group we actually collect data from. Now, you can collect data from the entire group, from the population, but it's very costly and very time consuming. Okay, and sometimes you don't get all the information you need. So I'm gonna go with this as well. Population is all or every. This is where you need to look for those words. Excuse me, I need to sneeze. Pardon me. One more. Nope. Pardon me. Okay. And then the sample is going to usually be a number. All right. The number is going to be part of the all or part of the every. All right. Label each as population or sample. So this is going to help you see really well, hopefully, how to understand the difference between a population and a sample. And I'm going to highlight the words that are extremely important to represent what we're looking at here. If you see all students of the college, or all registered voters in the county, or every smartphone in the U.S., those are all population. All right. Then if you'll notice, 150 randomly selected students, they're giving us a number. You're not going to get a number for population, only from sample. So 150 randomly selected students, 600 voters surveyed, 1,000 smartphones, those all have numbers associated with them. It tells you how many from the population they're pulling for the sample. So these three are the representations of the sample. Okay. A common misconception. Students often think the sample must be large to be representative. So what you need to understand, anytime you are studying population, any population, and you're going to have a sample, the most important thing by far of a study, whether it be an observational study or an actual experiment, is you want to make sure that the sample is a good representation of the population, because it's going to have to be representing it whenever you collect the data. You want the data from the sample, the numbers that you calculate from the sample, to be a representation of the population. So you want your sample to be a good representation of the population. Okay. Clarification: size matter, but method matters more. A large biased sample is worse than a small random one. Random is always the better way to go. Okay. An example: a biased online poll with 20,000 voluntary responses is less accurate than a random poll of 800 people. Let's start off talking about online polls. Who's more apt to fill out an online poll? Just sticking with males and females. Good luck getting a man to actually respond to an online poll. Okay, it's just not something you're typically going to hear. So the majority of the online polls, unless they are just have nothing better to do with their time, it's usually going to be done by women. All right. You want to be able to have your sample a good representation of your population. And so you want everyone to have the same chance of being in the sample that are in the population. All right. So a numerical summary. So this is a parameter. Let's go back to my drawing of JCC students. We've got them all in here. And this is our population. Okay. And then I said the subset is our sample. So a numerical summary of a population and it says fixed but usually unknown. It doesn't change. So what this is when you take data, if you can collect data from every single person, item, whatever in your population, and you can total those numbers, or you can take the averages or percentages, those averages, percentages, and totals are a parameter. So the easy way for me to always remember this is that population, the numbers associated with the population, or the, well, it helps if I can spell it, parameter. All right. Whereas our sample, it's a numerical summary of a statistic. I'm sorry, of a sample. A statistic is. And it's used to estimate the population parameter. So let me explain this one a little differently. If the numbers that we gather all the data from the population, all of it, and we do the percentages or the averages or the totals, then those calculations are your parameter, and it's based on the numbers you get from the population, the entire group. If instead you collect data only from the sample, and then you do the percentages or the totals or the averages, that is called a statistic. Statistic has a couple meanings. Notice population and parameter both start with P. Sample and statistic both start with S. It's easier for you to understand that. So here's the guiding idea. If the number describes a population, it is a parameter. If a number describes a sample, it's a statistic. All right. Okay. So the next thing is a helpful chart. Population is to parameter. I'm going to get overkill here. Sample is to statistic. So we're going to write parameter or statistics for each of these four. All right. We first need to find out, when we're looking at these, is it a representation of data that's been gathered from the population, or is it a representation of data that's been gathered from the sample? And that's what's going to guide our answers for these four. So the average GPA of all students at the university, all I need to see right there is all students. And that tells me that the information came from the population. So this is a parameter. The average GPA of 50 randomly selected students. There's my number. That means it's a stat. It's a statistic. The next one is the proportion of all voters. That is based on our population, so that is a parameter. And then lastly, the proportion of surveyed voters who support a candidate. So are they surveying all voters? Nope. There's no number with this, so be very careful. This is a specialty one. It's the proportion of surveyed voters who support a candidate. Not all voters, just the ones who support a candidate. So this has to be a statistic because it is based on a sample of the voters. Statistic. All right. Here's a trick for you. Look at the group the number refers to. And I wrote this earlier, but I'm going to do it again. If it refers to all, every, entire, or whole, it is a parameter because it's based on the population. If it refers to sample, survey, selected, or subset, it is a statistic because it's based on the sample. All right, last one for this group, the last section for this, is label each as a parameter or statistic. Please pause the video, attempt this part yourself, and then come back to see how you did. It says 25% of the 120 students in our sample prefer online classes. Well, if there's 120 students and only 25%, well, first of all, it's 120 students. That in itself, along with the fact that it says the word sample, tells me it has to be a statistic. 52% of all adults nationwide, support the new policy, according to a national census. So because it says all adults, then this has to be a parameter. It's based on the population. The average of 40 sampled apples was 142 grams. Again, they're saying the word sample, so this has to be a statistic. They also have, I can't spell, statistic. Good Lord. There we go. The true average weight of all apples in the orchard is unknown, so that is a parameter based on the population. All right, today we're learning how to gather and organize data. One of the most important skills in statistics. All right. The instructor asked, which I did, what is your favorite type of music? And we got responses. Those responses are called data. What is the unit here? And the unit is each student. Each student was our unit that we collected data on. All right. I'm going to go ahead and finish 2 and then we'll go to 3 in a different video. Units of study and types of data. A unit is equal to the individual being measured or questioned. It's who we're collecting the data on. Data is equal to the measurement collected or the answers. All right, we've got a couple different types of data. One is categorical data, which is also called qualitative. The other one is quantitative data, which is numerical in value. All right, categorical or qualitative, it consists of labels, names, or categories. It describes qualities and it does not involve numbers. You can do math. Does not involve numbers, it's not a hashtag, that you can math. So you can't take the averages of them. It doesn't make sense if you do. You can't take the sums or the adding of them. You can't find percentages of it because it just doesn't make sense. And we'll discuss that here in a moment. Quantitative or numerical, it consists of numerical values. So numbers that represents amounts or measurements. Okay, because these are numbers, here's what I need you to understand about this. There could be numbers over here, but the numbers in the quantitative, to know if the number is quantitative, you can math with these numbers. You can math with these numbers. So that means you can find averages. You can find percentages. You can find totals. And they make sense whenever you do so. Okay? Okay, let's fill in the type because this is where we're going to have our really good conversations. For the favorite food, that has to be categorical because what are your answers? What answers could you get if I asked you what your favorite food is? Say Mexican, Italian, American. So your favorite food is going to be categorical data or qualitative. Shoe size. So if I asked our entire class what their shoe size is, can I take, because that's going to be a number, because it's a number, I need a question, which type of number is it? Can I take the average of the shoe size to find the average shoe size for our class? Yes, I can, and it would make sense. Or find out what percentage has a specific shoe size. We can do that as well. So that's quantitative. Marital status. What are some options for answers for marital status? Single, divorced, widowed. Those are going to be categorical. There's no numbers involved. I don't even have to think about that. And then lastly, we have GPA. Well, can we take the GPA of everyone in our class and find the average GPA for our class? Of course we can. So that's quantitative. Notice that the two quantitatives are numbers, and they're numbers that we could take the average of, or percentages of, or sometimes totals. Numbers that only label categories, like jersey numbers, are still categorical. All right, so let's talk about that. If I took zip codes of everyone in my class, in our class, and could we take the average of that? Could I take 2 zip codes and from different locations and take the average and find out the middle city? No. Social security numbers. We could do the same thing in class. If we asked everyone their social security number, and could we take an average and would it mean anything? Our J numbers, our, phone numbers? Gosh, there's so many numbers that are actually just labels. They're representations. Your driver's license number. Think of any number that is a representation of a label and not a representation of a measurement. Okay? Those are going to be categorical if they label. Surveying everyone in a population would be a census. 2 popular examples are voting and the population census that is taken every 10 years. All right. What issues may be encountered with both of these examples? Well, with voting, typically not everyone votes. Everyone who's a registered voter may not vote, so you're missing out on your population gathering data. That's possible, or maybe they're old enough to register for vote, but they don't. What else? They vote improperly and they don't vote the way that they normally would. There's lots of different things that you can do for voting. Population census. So there's a couple different ways they do the census. One is they mail a letter, a card, and we fill it out. Either we fill it out online or we mail it back. The other is if those who don't do that, they'll send people around to the different houses, knock on the doors, and try to gain the information that way. So that in itself is an issue because not everyone's going to answer the door if they don't know who it is or they're worried. There's lots of different options there. All right, that is it for this video. I will see you in the next one.